Hello, space enthusiasts and curious minds. Welcome back to our channel, where today we dive into a groundbreaking announcement that has the scientific community and dreamers alike buzzing with excitement. NASA has just confirmed the discovery of vast oceans of liquid water on Mars. Strap in as we explore what this means for science, Mars colonization, and the future of human space exploration. Don't forget to hit that subscribe button if you haven't already to stay updated with the latest cosmic news. In a thrilling update from the world of science, researchers have uncovered a colossal underground reservoir of liquid water on Mars. This discovery isn't just significant, it's transformative. The reservoir is vast enough to envelop the entire Martian surface in a layer of water nearly 1 to 2 kilometers deep, or about a mile. This finding addresses a long-standing question: what happened to all the water on Mars? Once upon a time, Mars bore little resemblance to the barren, arid world we see today. Billions of years ago, the planet boasted a denser atmosphere and a warmer climate, creating conditions favorable for liquid water to flow freely across its surface. How can we be so sure? 3 crucial pieces of evidence paint a clear picture of Mars' watery past. First, the landscape of Mars is crisscrossed with valleys and outflow channels, strikingly similar to river valleys and deltas here on Earth. These intricate networks suggest that water once traversed the Martian terrain, sculpting channels and leaving behind layers of sediment. Second, the presence of hydrated minerals provides compelling proof. Orbiters like the Mars Reconnaissance Orbiter and rovers such as Curiosity have detected clays, sulfates, and specific types of salts minerals that only form in watery environments. This points to a historical presence of water necessary for such minerals to develop. Lastly, discoveries by Martian rovers of sedimentary rock formations further support the idea of an ancient, watery Mars. This trio of evidence combines to reveal a once vibrant, dynamic Mars, a stark contrast to its current state, and a testament to the planet's dramatic evolution. In an engaging twist to the Martian saga, scientists have revealed how water-related processes on Mars mirror those on Earth. The sedimentary rock formations found on Mars showcase features like cross-bedding and ripple marks, both typically formed by flowing water. However, the plot thickens when we consider Mars's dramatic history from about 3 to 4 billion years ago. A series of catastrophic events fundamentally changed the course of the planet. It all started with the collapse of Mars' magnetic field. Unlike Earth, Mars lost its protective magnetic shield relatively early. This shield, generated by a dynamo effect within the planet's molten core, would have protected Mars from the harsh solar wind streams of charged particles emanating from the Sun. As Mars' core cooled, the dynamo effect diminished, eventually causing the planet to lose its magnetic field. Without this protective barrier, the Martian atmosphere was at the mercy of the relentless solar wind. Over millennia, the solar wind eroded the atmosphere, causing it to thin and the atmospheric pressure to plummet. This thinning made it increasingly difficult for liquid water to exist on the surface. Water began to evaporate and dissipate into space. The disappearance of water was accompanied by a significant cooling of the planet. As the atmosphere thinned, it could no longer trap heat, weakening the greenhouse effect and causing temperatures to drop sharply. Mars, once a possibly warm and watery world, transitioned into the cold, dry planet we recognize today. This transformative period in Mars's history highlights the dynamic and volatile nature of planetary environments. As Mars transitioned from a warm and wet environment to the cold, arid expanse we observe today, any remaining water froze, forming layers of surface ice and permafrost hidden deep beneath the Martian crust. Yet, a puzzle persisted. The calculations showed that even after much water was lost to space, there should still be a substantial amount remaining. The ice at the poles was simply not enough to account for it all, which begged the compelling question: where was the rest of Mars' water hiding, and could it still harbor life? The answer to this Martian mystery came from NASA's InSight lander, a revolutionary mission tasked not with roaming the surface, but with probing the secrets beneath it. InSight was designed to delve into Mars's internal structure by measuring its seismic activity, heat flow, and internal composition. Over its 4-year mission, InSight detected over 1,300 Marsquakes, originating from meteor impacts and underground volcanic activity. These quakes sent seismic waves rippling through the Martian subsurface, which geophysicists could analyze to gather clues about the planet's inner layers. Buried within the data from these seismic tremors was an astounding find, a vast reservoir of liquid water. This discovery, made possible by InSight's deep dive into the Martian underground, reshaped our understanding of Mars and its potential to support life, stirring excitement and curiosity in the scientific community and beyond. The method used to uncover this hidden Martian reservoir mirrors techniques seismologists employ on Earth to study our planet's interior. By analyzing the behavior of seismic waves as they pass through different materials, scientists can deduce the properties of those materials. To pinpoint this concealed Martian water, researchers utilized a mathematical model akin to those used on Earth for mapping underground aquifers and oil fields. The model suggested that the seismic data could be best explained by a deep subterranean layer of fractured igneous rock, its crevices brimming with liquid water. Igneous rocks, which form from the cooling and solidification of molten rock, either as magma beneath the surface or lava above it, are common in diverse geological settings such as under volcanoes or in lava flows post-eruption. As these rocks cool, they often develop fractures and cracks that can serve as conduits for water, storing it within their fragmented spaces. Over time, processes like weathering can expand these cracks, enabling more water to infiltrate. Although igneous rocks are not typically known for being particularly porous or capable of retaining large amounts of water, they can indeed hold significant water under the right conditions. This discovery is not just a milestone in understanding where Mars's water has been hiding. It also crucially informs our understanding of the Martian water cycle and its potential to support life, providing fresh insights into the dynamic processes shaping this distant world. This newfound layer of liquid water is buried deep beneath Mars's surface, between 11.5 and 20 kilometers or 7 to 13 miles deep, placing it well beyond the reach of future astronauts or any current technology. Even on Earth, drilling to such formidable depths remains an extraordinary challenge. While the presence of liquid water on Mars doesn't guarantee the existence of life, it undeniably sparks fascinating possibilities. The conditions within this hidden reservoir could mirror those on Earth where extreme forms of microbial life thrive, like in the depths of mines or the ocean floor. Scientists speculate that if habitable conditions do exist on Mars, they're most likely nestled deep beneath the surface. This discovery not only deepens our understanding of Mars's water cycle, but also its potential as a cradle for life. If life ever took root on Mars, or still clings on it, may well be lurking in these secluded underground aquifers, awaiting discovery. The revelation of such a vast water reserve on Mars tantalizes us with visions of the red planet as a potential future habitat. Yet, the journey to setting foot on Mars teems with formidable challenges. One of the most significant obstacles is the sheer distance averaging about 225 million kilometers, or 140 million miles, and the lengthy travel time required to reach it. The road to Mars is long and filled with hurdles yet to be overcome, but the quest to unlock the planet's secrets and possibly its habitable future continues to inspire awe and determination. Embarking on a round-trip mission to Mars is no small feat. Traveling to the Red Planet, conducting operations, and returning to Earth would span approximately 18 to 30 months. During this time, astronauts must carry enough supplies to last throughout the mission. The vast distance, about 140 million miles, also means that any immediate help from Earth would be delayed by minutes, complicating responses to any emergencies that might arise. The second major challenge is radiation exposure. Space teems with harmful cosmic rays and solar particles that present serious health risks. On Earth, our magnetic field shields us from much of this radiation, but Mars offers no such protection. As a result, astronauts would face significant radiation exposure during their journey and stay on Mars, increasing their risks of cancer and other health issues. The third challenge lies in Mars' harsh environment. The planet experiences extreme temperature fluctuations, from chilling lows of 125 degrees Celsius, 193 degrees Fahrenheit, at night to highs of around 20 degrees Celsius, 68 degrees Fahrenheit during the summer days. Mars is also prone to frequent, sometimes planet-wide, dust storms that can last for weeks or months, disrupting solar power generation and potentially damaging essential equipment. Ensuring the safety of astronauts and the integrity of their equipment under these conditions is a formidable task. The fourth hurdle is creating a robust life support system. Sustaining human life on Mars demands highly reliable systems to manage essentials like air, water, and food. Each of these challenges must be met with innovative solutions to make living on Mars a viable possibility. On Mars, unlike Earth, the atmosphere is thin and composed mostly of carbon dioxide, with scant oxygen and almost no accessible water. This stark reality means that astronauts will require sophisticated life support systems designed to generate oxygen, recycle water, and produce food on Mars or carry sufficient supplies for the entire mission. The reliability of these systems is critical, as any malfunction in Mars's unforgiving environment could prove catastrophic. The final hurdle is safeguarding the physical and mental health of the astronauts. The prolonged exposure to microgravity during transit can lead to muscle atrophy, bone density loss, and other health complications. Once on Mars, the planet's lower gravity, just 38% of Earth's, might also present unforeseen challenges to human physiology. Beyond the physical, the psychological strains of isolation, confinement, and the vast distance from Earth pose significant risks of stress, anxiety, and depression among the crew. Ensuring the well-being of astronauts throughout such a mission demands meticulous planning, continuous support, and creative health management strategies. The recent discovery of a vast water reservoir on Mars introduces an exhilarating chapter in our understanding of the planet. It not only deepens our grasp of Mars's climatic and hydrological history, but also expands the scope for future missions. Although tapping into this Martian water source remains a long-term aspiration, it fuels our imagination and propels forward the possibilities of human exploration and perhaps even settlement on the Red Planet. The recent discovery of an extensive water reservoir on Mars fuels our imaginations about the boundless possibilities as we delve deeper into understanding and exploring the Red Planet. In a related vein of space exploration, China has recently made headlines by returning a sample of lunar soil from the far side of the Moon. With their string of successful missions, they are positioning themselves as potential pioneers in establishing a permanent base on the Moon. If you haven't yet heard about this remarkable achievement, make sure to catch up on this thrilling development in space exploration. This incredible discovery comes from NASA's latest data gathered by the Mars Reconnaissance Orbiter, which has been circling the Red Planet and sending back detailed imagery and data for over a decade. Scientists have now confirmed patches of liquid water spread across Mars in what they describe as subsurface lakes. Each about the size of Lake Tahoe, these reservoirs lie beneath the planet's icy crust in the southern polar region. Water is life, and the presence of liquid water on Mars opens up thrilling possibilities about life beyond Earth. Researchers are particularly excited as these Martian oceans could host microbial life forms, adapting to extreme conditions. This segment of the discovery not only reshapes our understanding of life in the universe, but also directs future missions to specific sites on Mars. The discovery was made possible through advancements in radar imaging technologies and satellite sensing. The orbiter's instruments peered beneath the planet's surface, through layers of ice and dust, to detect liquid water signatures. This breakthrough not only paves the way for more targeted explorations, but also improves our capabilities in exploring other celestial bodies in the solar system. The discovery was made possible through advancements in radar imaging technologies and satellite sensing. The orbiter's instruments peered beneath the planet's surface through layers of ice and dust to detect liquid water signatures. This breakthrough not only paves the way for more targeted explorations, but also improves our capabilities in exploring other celestial bodies in the solar system. With Mars proving to be more Earth-like with reservoirs of water, the implications extend beyond immediate space travel. This discovery prompts a broader conversation about our place in the universe, resource scarcity on Earth, and our responsibilities as a spacefaring civilization. It also raises ethical questions about space colonization and the preservation of extraterrestrial environments. Mars has been a focal point of space exploration for decades, with countless missions dedicated to understanding the Red Planet. From the first flybys in the 1960s to the more recent rovers like Curiosity and Perseverance, each mission has revealed something new about Mars. This latest discovery of liquid water is the culmination of years of scientific effort, proving that persistence in exploration pays off. It also underscores the importance of continued investment in space missions, as every piece of data collected brings us closer to significant breakthroughs. The detection of water beneath Mars' surface wasn't a straightforward task. Scientists used a technique called radar sounding, where radio waves were sent to the Martian surface. These waves bounce back with varying intensity depending on the materials they encounter. The data suggested the presence of liquid water, confirmed through multiple observations. This method is groundbreaking, offering a template for detecting similar bodies of water on other celestial objects, like Europa or Enceladus, furthering our quest to find extraterrestrial life. Mars's climate plays a crucial role in the presence of liquid water. The planet experiences extreme conditions, with temperatures plunging far below freezing. However, the subsurface lakes remain liquid due to the high concentration of salts, which lower the freezing point of water. This briny water could be a haven for life, akin to extremophiles on Earth that thrive in similar harsh environments. Understanding Mars's climate also helps scientists model the planet's history, potentially unlocking secrets about its wetter, warmer past. The discovery of water is a game-changer for human habitation plans on Mars. Water is a vital resource, not just for drinking, but for producing oxygen and hydrogen-critical components for breathable air and rocket fuel. Establishing a colony near these water sources would reduce the need to transport large quantities of water from Earth, making Mars colonization more viable. Furthermore, the ability to extract water directly from Mars aligns with the concept of in situ resource utilization, a key principle in sustainable space exploration. With the discovery of water and the potential for life, ethical considerations become increasingly important. If Mars harbors even the smallest forms of life, we must question the morality of colonization. Do we have the right to alter or potentially destroy a native ecosystem? This discovery sparks a necessary debate about how we, as a species, should approach the exploration and utilization of other planets. It challenges us to consider not just the scientific and economic benefits, but also the ethical responsibilities we hold as explorers of the universe. The concept of terraforming, modifying a planet's environment to make it habitable for humans, has long been a topic of speculation. The presence of liquid water on Mars provides a critical piece of the puzzle. While we're far from being able to transform Mars into a second Earth, the discovery gives hope that, with the right technologies, we might one day make parts of Mars habitable. Welcome to Blessovia Science TV, where we take you on an exhilarating journey through the cosmos and unravel the mysteries of science. We are excited to offer you the opportunity to become a valued member of our ever-growing community of cosmic enthusiasts and knowledge seekers. Exclusive access to cosmic content. As a member of Blessovia Science TV, you will gain exclusive access to a treasure trove of cosmic content, including documentaries, interviews with leading scientists, space missions updates, and awe-inspiring visualizations of the universe, live Q, and sessions with experts. Your membership will grant you the chance to participate in live Q and sessions with renowned scientists, astronomers, and space explorers. Get your burning questions answered by those who push the boundaries of human knowledge. Embark on a journey that spans the cosmos and join us in unraveling the secrets of the universe. Become a Blesovia Science TV member today, and together we will reach for the stars. Thanks for watching. Subscribe, like, and share. Don't forget to leave your comment.